Well, hi there, boys and girls. Today we're going to learn my favorite application of tangent lines, and that's actually using the math to approximate something that we cannot do in our head or even by hand. Or at least if you were able to do it by hand, it's actually very difficult, and the tangent line might be just as good. So it depends on your level of accuracy you're looking for. So let me show you what I'm talking about. This tangent line to this curve we drew yesterday, this tangent line touches the graph at the point 3. We centered this at 3, or we made this tangent line at the x value of 3. We also want to notice that a little to the left of 3 and a little to the right of 3, we can't really see a difference in these two graphs. And what I mean by that is the y values are not very far apart. And if we zoomed in a little bit here, if I zoomed in close to where we centered this, which was out here at 3, get up there on the curve, so we zoomed in somewhere close to 3, and we can see that the tangent line and the graph are really close to each other. And this was a graph of a square root. Now, you know square roots of nice pretty numbers like 1, 4, 9, 16, 25, but not many of us know square roots of like 4.9 or 8.1 or things like that. But we can, however, find out the value of a tangent line at those places because we just plug them into a y equals mx plus b, and it's really easy to multiply and add. Let me go to a table and show you what else I'm talking about. We centered this at 3. In this column y1, you see the actual values for the square root of x plus 1. Over here in y2 are the tangent line values. Of course, at 3, we centered it there, so they better match at 3. A little to the left of 3, look how close the tangent line is. As a matter of fact, the calculator can't tell a difference at 2.99. And at 2.9, the actual value is 1.9748, and the tangent line is 1.975. That's pretty close. And even out here to the right, you can see that the tangent line's y values are really close to the square root's y values. Now let me show you why this is really important. Let's say that you wanted to approximate the square root of 4.1. And you wanted to do this, maybe with a little sheet of paper. Now, there is an algorithm to do a square root, but it takes about 7.5 days to do. And it takes 1,000 steps, and it's ugly, and it's mean, and it's whatever. So let me show you how we can use the tangent line to approximate the square root, and let's see how good it is. First of all, I'm going to use the tangent line by making a tangent line. And of course, we've done y minus y1 equals m times x minus x1. I'm going to go ahead and add the y1 to both sides, and this is the version that I'm going to use, y1 plus m times x minus x1. However, our m, which means our slope, we're going to calculate what there? We're going to calculate a derivative. So what function am I dealing with? The function I'm trying to approximate is f of x equals the square root of x. I would like to be able to take the square root of some numbers. So what is f prime of x? Well, we know from the power rule that this is 1 over 2 square roots of x. Now, the next thing we need to decide is where are we going to write this tangent line? Are we going to write this tangent line at the square root of 9? Are we going to write it at 16? What I'm asking is what x value are we going to use? Now, since we want the square root of 4.1, we need to pick a value for x that's close to the square root of 4.1 that I can actually find the square root of. What I mean is there a number close to 4.1 that you know the square root of? And of course there is. 4. We know the square root of 4. So I'm going to use this terminology. I'm going to center this at 4. And that's terminology for saying we are going to let 4 be our x1. So we are going to center it at 4 comma something. And how do we find that y coordinate? Well, we plug it into the square root of x. So we're going to draw a dot at 4, 2, and that's where we're going to write our tangent line. Okay, I'm also going to, well, let's just go ahead and do this. So I'm going to get y equals 2 plus, now what's the slope? Well, the slope is we plug 4 into our tangent line equation, so I want f prime at 4, and I get 1 over 2 square roots of 4, which is 1/4. All right, fine. That goes there. And then x minus x1. There's a tangent line equation to the square root of x curve centered or at x equals 4. And I'm going to give this a fancy notation. I'm not going to call it y. I'm going to call it t of x. T stands for the tangent line approximation. T of x equals 2 plus 1/4 times x minus 4. All right, so what, Mr. G? What does this mean? Well, this means that I can say that the square root of 4.1 is the same thing as asking what is f of 4.1 when f of x is the square root of x. Well, I don't know that. I don't actually know the square root of 4.1. I cannot tell you at the top of my head what that is. Of course, I could ask a calculator, but I don't know how to do that. However, I can say that that's approximately equal to the tangent line at 4.1. Why is that? Well, we saw from the graph the tangent line stays really, really close in y values to the actual function value. Well, why would I want to do this? Well, take a look at this. These calculations you could have done in, I don't know, 4th, 5th grade. Plug 4.1 into a y equals mx plus b form, and you just got a little bit of fraction work to do. So we do 2 plus 1/4. 4.1 minus 4 is 0.1, sorry. I'm going to call that 1/10. Now that is 2 plus a 40th. Now 1/4 is 0.25, so 1/40th is 0.025. So my tangent line would have a value of 2.025. That's my tangent line at 4.1. And what I'm saying is that that's approximately equal to the square root of 4.1. Let's go ask the calculator if we're even close. Is 2.025 close to the square root of 4.1? Square root of 4.1. And we said 2.025 was where the tangent line was. And this says 2.02484. Oh yeah, look how close that is. All the way out here to the, well, even if we rounded out here to the 10,000th place, it'd be 2.025. And look how easy that was. I did calculus combined with 4th grade math, and I took the square root of 4.1, and I was close enough to build a spaceship. Let's go take a look at another example. Use a tangent line to approximate the cube root of 8.1. Cube root of 8.1, I can't do that, but wait one second. I want to approximate some values on x to the 1/3. So let's use the tangent line to that curve and use the tangent line instead. Why use the tangent line instead? Because that's just y equals mx plus b. Anybody can multiply something and then add, but I don't know how to take the cube root. So let's write the tangent line equation. Next thing we need is f prime. F prime is 1/3 times x to the negative 2/3, which is the same thing as 1/3 x to the 2/3 power. Now, where are we going to write this x value? Or where are we going to write this tangent line to the cube root? We want to pick a number that's really close to 8.1, but we've got to pick a number that we know the cube root of that number. Well, guess what? We know the cube root of 8, so I'm going to write the tangent line where x equals 8. Now I'm going to use my fancy notation. T of x is going to equal, our y1 plus m times x minus x1. And we're going to be at the point 8 comma something. And what's the y value? Well, the cube root of 8 happens to be 2. So we'll write the tangent line at 8 comma 2. Let's go ahead and do that. So my tangent line equation is y1 plus, now what's the m? What's that stand for? That's the slope. So what do we plug into this derivative? We plug in 8. So I want to do f prime at 8, which would be 1/3 times 8 to the 2/3. Now, fractional exponents give some people some fits, but fractional exponents are power over root, and it's often easier to take the root first and then do the power. You can do them in either order. What I'm saying is I could do 8 squared and then the cube root of that, or I could do the cube root of 8 and then square it. And since you don't have a calculator, it's much easier to do the root first because it keeps the number smaller. So I've got 1/3 times the cube root of 8 is 2, and 2 squared is 4, and that's 1/12. Now let me tell you something. You need to know what 1/12 is as a decimal, because if you ever get raises and it's split out over 12 months, you're going to want to know how much you get. So let's just say you get a $1,000 raise split out over 12 months. That's $83.33 a month. The reason I know that is because I've worked my entire life. But I also know that 1/12 as a decimal is 0.083 repeating. You need to know that. Every $1,000 is $83.33 a month. All right, but I'm going to plug this in. So 1/12 happens to be my slope, and then x minus x1. Well, x is where I'm trying to approximate this. That's 8.1 minus 8. Oh wait, I don't want to use 8.1 yet. I just want to use x minus 8. So I can write my tangent line equation. So here is my tangent line equation to the cube root function centered at a. And we want to know the cube root of 8.1. So I'm going to say that's approximately equal to the tangent line at 8.1, which is equal to 2 plus 1/12 times 8.1 minus 8. And that is 2 plus 1/12 times 1/10. Now, if you know 1/12 is 0.083 repeating, 1/10 is just move the decimal over once. So that's 2 plus 0.0083 repeating, which is 2.0083 repeating. That is what I think the cube root of 8.1 is. I multiplied and added. Ooh, that was difficult. Let's go see how we did. 2.0083 repeating, and we wanted the cube root of 8.1. That's the same thing as 8.1 raised to the 1/3 power. We said it was 2.0083. Oh my gosh, look at that. I don't need no stinking calculators. I got a tangent line. Deuces.